When you've completed this lesson, you should be able to write decimal numbers in scientific notation and also write numbers that are in scientific notation back into decimal notation. Now, photonics technicians need to use very large and very small numbers, and so to write these numbers in a calculator or into a computer, we really need to use scientific notation. So, for example, for the speed of light, rather than writing 30 billion centimeters per second, we'll use a number like 3.0 times 10 to the 10 centimeters per second. Or for Planck's constant, h, rather than all those zeros followed by 6625 joule seconds, we can use the number 6.625 times 10 to the minus 34 joule seconds. We'll learn in this module how to write those numbers. Now let's look at an example problem. Suppose your supervisor asks you to calculate the energy of a photon from a certain laser. You know the formula for that photon could be calculated from a formula E is equal to hc over lambda, where h is Planck's constant, c is the speed of light in a vacuum, lambda is the wavelength, and E is the energy in joules. Now you'll notice those first three constants are all given in terms of scientific notation. They're either very small numbers or very large numbers. You'll have to use scientific notation to make those calculations. In this module, we'll learn how to do that. But we'll return to this problem later after you've learned how to deal with these numbers in scientific notation. Now, scientific notation is essentially a way to write numbers that are very large or very small. So let's recall some powers of 10. You know that 10 to the 1, for example, is 10. 10 to the 2 is just 10 squared, which is 10 times 10, which is, 100. 10 to the 5th power, then, is 10 times 10 times 10 times 10 times 10, which is 1 followed by 5 zeros. Do you see the pattern here? That's going to be our secret as we move along here. So a few definitions and terms are important for us. Scientific notation is a prefix followed by a base and an exponent. The prefix is a number between 1 and 10, not including 10, and followed by a power of 10, which is a base and an exponent. The base is always going to be 10 in scientific notation, and the exponent is that integer up in the top. The prefix and the exponent can always be positive or negative. So you could have negative 3.14 or positive 3.14. Or you could have 10 to the positive 11 or 10 to the negative 11, as you see in those examples here. Now let's write some large numbers. We can write any large number as a prefix times a power of 10. So for example, 100 could be 1 times 100, which is 1.0 as a prefix times 10 to the 2. That's a number in scientific notation. 150 is 1.5. That's a prefix times 10 to the 2, which is the base and the exponent. That would be the number in scientific notation. Or 3,750 would be 3.75 times 10 to the 3. 3.75 times 10 to the 3 is a number in scientific notation. Or 37,500 would be 3.75 times 10 to the 4th. So how do we determine that 10 to the 4th? Well, we start by determining how many places we have to move that decimal point to get the prefix between 1 and 10. And we see here that we had to move the decimal point 4 places, and that became our exponent. So let's recall that very large number. Remember that 314 billion? Well, in this case, we have to move the decimal point 11 places in order to get the 3.14, a prefix, between 1 and 10. So that gives us our number of 3.14 times 10 to the 11th is in scientific notation. Now we can also write very small numbers in scientific notation as a prefix times a power of 10. So 0.1 is the same as 1 times a tenth, which is 1 times 10 to the minus 1. Notice that 1/10 is the same as 10 to the minus 1 power. Or 0.01 is the same as 1 times a 100th. And 100th is the same as 1 over 10 to the 2, which is the same as 10 to the minus 2. So there's our number in scientific notation. 0.01 is the same in scientific notation as 1.0 times 10 to the minus 2. 0.015 is 1.5 times 1/100th, or 1.5 times 1 over 10 to the 2, or 1.5 times 10 to the minus 2. So, remember that very small number, that 314 with preceded by lots of zeros. In the same way, we can count how many places we have to move the decimal point to get to that prefix, and we have 3.14 times 10 to the minus 7. So we can write large and small numbers. Large numbers have positive exponents, like the speed of light is 3 times 10 to the 8th meters per second. Cordless phone frequency is 2.4 times 10 to the 9th hertz. In our galaxy, there's a lot of stars, about 5 times 10 to the 11th stars. Or we can write small numbers that have negative exponents, like the wavelength of laser light is a very short distance of 6.1 times 10 to the minus 6 meters. Or the clock cycle on a supercomputer is a very short amount of time, 2.6 times 10 to the minus 13th seconds. And the mass of a proton is 1.7 times 10 to the minus 27 kilograms. Very small weight. Now, why do we call it scientific notation? Well, because engineers and technicians and even scientists often work with very large and very small numbers. And so we have to come up with a way to put those numbers into calculators and computers. It makes it much easier to put those numbers into tables and references because those such large and such small numbers. It's often necessary to deal with calculators that can only hold 10 digits. But we can't use all those digits up just to have all these zeros. And so we'll use scientific notation to communicate that those places are actually just placeholders. Later we'll see a slightly modified version of scientific notation called engineering notation. So how do we write numbers in scientific notation? First of all, locate that decimal point. As in 81,000, the decimal point is right after that last zero. Count how many places we have to move that decimal point to the left. In this case, we have to move it 4 places to get a prefix that's between 1 and 10. And the number of places that we have to move that decimal point becomes our positive exponent. So we have 8.1 times 10 to the 4th. If we do a check, 8.1 times 10,000, which is the same as 10 to the 4th, sure enough, we get back our original number of 81,000, and we are confident that we've done everything right calculating our scientific notation value. To write small numbers, as before, we locate the decimal point. There it is, right before that 0.0715. We count the number of places, this time to the right, that we have to move the decimal point in order to get a prefix, which is between 1 and 10. In this case, it's 2 places to the right, and that number of places becomes our negative exponent in this case. 7.15 times 10 to the minus 2. So we have our number with our new decimal point location and the power of 10 with our exponent of minus 2. As before, we should always check our work. 7.15 and 10 to the minus 2 is the same as 0.01, and that yields, sure enough, 0.0715, our original value, and so we're confident that we did our work correctly. Here are some more examples that you can see that we have the ability to write very large and very small numbers in scientific notation. Notice that each one is a prefix between 1 and 10 multiplied by a power of 10. Engineering notation is just slightly different from scientific notation because the exponents are always multiples of 3. So for very large numbers, our exponents will be like 10 to the 3 power, 10 to the 6th power, 10 to the 9th power, 10 to the 12th power, and so on. And you'll notice that those conveniently correspond to the prefixes that you are used to seeing in the metric system, as in kilo, kilometers, and kilograms. Or mega is a prefix, as in megahertz, or giga, tera, and peta. And similarly, for small numbers, we have 10 to the minus 3, minus 6 or minus 9 and so forth. And those also correspond to metric prefixes that you've seen for the small numbers, as in millimeters and micrometers, nanometers, picometers, and so on. Comparing scientific notation and engineering notation, as shown in Table 2 in your text, you'll notice that there is sometimes convert from scientific notation to engineering notation. If we have a number like 3.5 times 10 to the fourth, to convert that to engineering notation, to get that exponent to be a multiple of 3, we're going to have to change 3.5 to 35. Or 8.4 times 10 to the 8th, to get that 8 into a multiple of 3, we'll go to 6, we'll have to change 8.4 to 840, and so on. In each case, the prefix in the scientific notation is always between 1 and 10, but in the engineering notation, you'll notice that the prefix can be between 1 and 1,000. So how do we do that conversion? Let's look at an example. Suppose we need to convert the speed of light to engineering notation. 2.998 times 10 to the 8th meters per second. Well, first of all, you'll notice that it is not in engineering notation. 10 to the 8th, the exponent 8, is not a multiple of 3. So we'll need to round that 8 down to the nearest multiple of 3, which in our case would be 6. In order to do that, we'd have to divide 10 to the 8th by 100 to get 10 to the 6th. So we'd have to also multiply the prefix by 100 to keep the same value. So we'll multiply the prefix by 100 and divide the exponent by 100. So we'll end up with 299.8 as the prefix and 10 to the 6th then as the base and exponent, as our number in engineering notation. Now, using a scientific calculator, we'll have to watch for the exponent key. It'll vary on different calculators. You'll either have the EE or the EXP, or in some cases just an E key for your exponent. So to enter the prefix, for example, with an EE key, to enter 9.87 times 10 to the minus 6, you would enter the digits 9.87, just like you would normally enter them. Then press the EE key for the exponent. In our case, we'd have to press a plus or minus key to get that negative in there, and then press the 6 key. That would enter the value 9.87 times 10 to the minus 6 into your calculator to be used in an operation. Now you have to be very careful to note that the negative exponents use a negative sign, not the subtraction sign on your calculator. The calculator answer that you get will also be shown in scientific notation. So it'll look like 1.171 with a little negative 94, or 3.72 with an E and a negative 16. Notice that that little negative symbol there tells you that that's an exponent of 10 to the negative 94, or 10 to the negative 16. If there's just a space there, that would be 10 to the positive 16, or 10 to the positive 94. You'll have to look very carefully and be aware that that number will be in scientific notation. To do math with your scientific calculator and scientific notation, enter the values with the exponent key and then do the operations as usual. The results may also be displayed in scientific notation. And so let's return now to the problem that we saw at the start of this lesson, where we did have some numbers in scientific notation. There's our formula with the numbers in scientific notation substituted. First of all, we can analyze the units. We'll notice that the seconds, joule seconds, will cancel with the meters per second. The seconds will cancel, and the meters in the meters per second will cancel with the meters in the denominator. So we're left with just joules. Now we can proceed to calculate the value with our scientific calculator. Enter the expression in your calculator as shown here for the TI-83 or 84 series of calculators. So you enter 6.625 followed by that exponent function and a negative 34, and times 2.998 and the exponent function and the power of 8, divided by 1.064 and the exponent function and the exponent of negative 6. Then you press the enter key to complete the evaluation. On the TI 30 series of calculators, you would enter a similar evaluation followed by the equal sign. And the result will be 1.8667 with the e to the minus 19, or 1.8667 just with a negative 19 there, indicating that the answer is 1.8667 times 10 to the minus 19 joules. The answer in scientific notation. And we can also convert joules to electron volts by multiplying by unit ratio. 1.867 times 10 to the minus 19 joules times 1 electron volt per 1.602 times 10 to the minus 19 joules. The joules will cancel, leaving us with electron volts. And if you'll enter that expression into your calculator, you will get 1.17 electron volts. Now let's look at some of the practice exercises that are offered for you in this module. We'll not solve every one of your practice exercises, but just a few to give you a sense of confidence that you can solve the rest of them yourselves. For example, to change large numbers to scientific notation, the average distance of Earth from the Sun is 92,960,000 miles. Well, how would we express that number in scientific notation? As you've seen, we would find the decimal point, move it over to form a prefix that is between 1 and 10. In this case, 9.296. We had to move the decimal point over 7 places. So that becomes our exponent. And our number in scientific notation then is 9.296 times 10 to the 7th miles. In summary, we locate the decimal point, count the number of places we had to move the decimal point. That becomes our exponent. We write our prefix, that decimal point after the left digit, and we have our number in scientific notation. Exercise 2 asks you to change small numbers to scientific notation. So, for example, we can have 1 atomic mass unit, which is that very small number of lots of zeros preceding the 166 kilograms. We can write that number in scientific notation by counting how many places we have to move the decimal point over to get a number of a prefix between 1 and 10. In this case, we had to move it 27 places to the right, so that becomes our exponent of 10 to the minus 27 kilograms. So again, in summary, we locate the decimal point, count the number of places to the left of that digit to get a single left digit, write the prefix with that decimal point after that left digit, and the exponent becomes the power of 10 with that number of places and a negative sign in this case since we had to move the decimal point to the right. We can do the reverse by changing large numbers that are in power of 10 notation to decimal notation. For example, the speed of light, 2.998 times 10 to the 8th meters per second, if we want to write that number in decimal notation. So 2.998, and we have to move that decimal point over 8 places. And we have to insert some commas to make it a little bit more readable. So in general, we locate the decimal point. For positive exponents, we're going to move the decimal point to the right that number of places, adding placeholder zeros if needed, as we did in this case. And insert some commas to assist in the reading of that very large number. We can change small numbers in power of 10 notation to decimal notation, such as the Boltzmann constant of 8.617 times 10 to the minus 5 electron volts by changing the 10 to the minus 5 is the same as 1 divided by 100,000. And we're going to do just the opposite. We're going to take that decimal point and move it to the left this time by how many places do you think? 5 places over, right? And we're going to have to insert some zeros to make that decimal point stay out there, and probably put a 0 out there at the beginning to hold it all in place. So again, in summary, locate the decimal point, move the decimal point to the left, the number of places of that exponent, inserting placeholder zeros if needed, and put an additional 0 out there in the front before the decimal point so that when we read it, we'll say 0.0000817 electron volts. Now, in general, we have some other numbers we may like to complete the prefix to change the number to power of 10 notation. It may not be scientific notation. It may just be some other power of 10 notation. And if we want this to be times 10 to the 9th, in this case we have to move the decimal place over 9 places, and so in this case it becomes 13.996 times 10 to the 9th, and you see how that works. I believe you can convert most any number by moving the decimal point over the correct number of places. And you may have to put some placeholder zeros if necessary. So for small numbers, similarly, if we have to move the decimal point over 9 places in this case, we may need an extra 0 to hold it out there. So you'll see that our answer will become 1,260 times 10 to the minus 9. We did need that extra 0 in this case. All right, so how do we use a scientific calculator just to make some calculations? Let's try it with Einstein's equation of E equals mc squared, where mass is equal to 4.61 times 10 to the minus 6 kilograms, and c, the speed of light, is 3.00 times 10 to the 8th meters per second. Well, on a TI-80 series of calculators, that would be 4.61, then enter the exponent of -6, times 3, enter the exponent of 8, and in this case we want to do the operation of x squared, then press enter to complete the operation. And similarly on the TI-30 series of scientific calculators, and if you have another brand of calculator, you would do a similar operation, and the result will be something like 4.149 e to the 11, or 4.149 with a space and 11, telling us that the answer for E is 4.15 rounded times 10 to the 11 joules. So in general, we enter the prefix, press the exponent key, and then enter the exponents with a plus or minus key, or negative key if necessary. Then you follow it with all of your operations as normal. You may need to use parentheses to make all that work out properly. I'm sure that you'll be able to do the rest of the practice exercises on your own, and you'll become proficient with scientific notation.